This video is your introduction to stoichiometry, there's the pronunciation on the screen, which is using ratios that you make from balanced equations as conversion factors in dimensional analysis. All of these notes and examples are from Reactions and Stoichiometry packet, page 6. So stoichiometry is your license to cross that mole ratio bridge. And so the word stoichiometry means, so element is what stoichi means, and then metry is like measuring. So really the word means to be able to like measure elements. And you're thinking, well, haven't we already done that with mole conversions using molar mass? And you're right, this is only slightly different. The setup for a stoichiometry problem is maybe gonna look the way the beginning of a mole conversion problem looked, like how many moles of calcium phosphate. But what will be different is on the other side, you'll be given maybe moles, maybe grams of a different chemical. And the way those two things are related would be through a chemical reaction. We would use stoichiometry so that we could calculate the amount of one reagent, like the moles of calcium phosphate, that could be produced in a chemical equation when we know the amount of a different reagent. So like in this case, we know the amount of moles of calcium. So the way we do this is we have a balanced equation and we interpret it two different ways. When you balance the equation, you were probably thinking of it on the micro scale, the way Tyler DeWitt demonstrated in the balancing equations video. You were picturing two molecules of hydrogen and one molecule of oxygen, and then visualizing those separating to form two molecules of water. So that's micro scale because micro means tiny. But when we start dealing with calculations of amounts of things produced by reactions, we think of them on the macro scale, big enough for us to see. So instead, we would consider this to be 2 moles of hydrogen combining with 1 mole of oxygen to make 2 moles of water. And now we've got sort of a recipe for how to make water, so we can make ratios of those ingredients in our recipe. So for example here, if they were looking at, well, what's the ratio of ingredients? It takes 2 moles of hydrogen for every 1 mole of oxygen in this reaction. And then you could also look at it in the reciprocal. For every 1 mole of oxygen, it's going to take 2 moles of hydrogen. So you can also look at it if you wanted to compare reactants to products. Like if I go in with 1 mole of oxygen, how many moles of water can I make? 2 moles of water can be made. If I'm going to make 2 moles of water, how much oxygen do I need to provide? That would be 1 mole of water. And so if you look at the mole ratio bridge, it gets you from moles of this chemical, so maybe from moles of oxygen, using a mole ratio from your balanced equation, you could calculate the number of moles of a different chemical. So let me change to pen, and this is the practice problem in the packet. So it asks, what are the mole ratios of calcium to calcium phosphate in this balanced reaction? So here's the calcium, and here's the calcium phosphate. I don't need to pay attention to any other component. I notice there are coefficients in place, so this equation is already balanced for us. So all I have to do is interpret those coefficients to be moles instead of atoms. So I would need 3 moles of calcium for every, no coefficient means a 1 mole of calcium phosphate. And then I could also use the reciprocal. For every 1 mole of calcium phosphate, I would need to provide 3 moles of calcium. So I've just made a ratio there. The problem that we looked at in the beginning said how many moles of calcium phosphate could we make if we had 4.7 moles of calcium. So then we would draw our line and decide which conversion factor would work here. It says moles everywhere. So the way we can tell which of these we need is we need the one that puts the moles of the correct chemical on the bottom. So we would put the 1 mole of calcium phosphate over 3 moles of calcium, letting the moles of calcium cancel, and then we would have to just divide the 4.3 by 3.